everyone. Well, in this video, we'll be starting with the next paper, GATE 2014, SET-1, and this is for the electrical engineering branch. Now, the first question says, given a system of equations, x plus 2y plus 2z equals b1 and 5x plus y plus 3z equals b2, which of the following is true regarding its solutions? So the four options given to us, the first one says, the system has a unique solution for any given b1 and b2. Option B, the system will have infinitely many solutions for any given values of b1 and b2. Option C says whether or not a solution exists depends on the given values of b1 and b2. And option D, the system would have no solution for any values of b1 and b2. So our four options talk about the type of solutions that we would get for the system of equations given. Now, in order to do this, you will notice that we have three unknown variables, x, y, and z. So to solve, let's start by writing the system given in matrix form. So let me just get another sheet of paper. Okay, so the given system is x plus 2y plus 2z equals b1 and 5x plus y plus 3z equals b2. So if we were to write it in the form of a matrix, let's call that A. This is going to be our augmented matrix. So we write down the coefficients of each of the variables here. So that's 1, 2, 2, b1, and in the second row 5, 1, 3, b2. So this is our augmented matrix. Now, to find out what type of solutions this system has, we will have to find out first the rank of this matrix A. Now recall, how do we find out the rank? We find it by using row and column operations. So in this case, let's use row operation to make the bottom left element here 0. Always remember that we always start with the bottom left element. So let's make this element 0. How do we do that? Now if you notice here, the row R2, so we have two rows here, R1 and R2. Concentrate on row R2. Now in order to make this element 0, we would have to do R2 minus 5R1. We utilize the element that is right above it in order to make this element 0. So the operation would be, the new row R2 would give us R2 minus 5R1. So let's try and solve this. What do we get here? So R2 minus 5R1 would be, okay, so first I'm going to write down what R1 is. R1, we write it down as it is. 1, 2, 2, and B1. Now let's see what happens to R2 here. 5 minus 5 into 1, that's 0. 1 minus 5 into 2, that's minus 9. And 3 minus 5 times 2, that's minus 7. And in this case, for the final element here, B2 minus 5 times B1. B2 minus 5 B1. So this is our new matrix. Now if you notice over here, we have two non-zero rows. Apart from making the final element here, the bottom left element as 0, we see that we still have two non-zero rows. So this implies that the rank of the matrix A is 2, because the rank equals to the number of non-zero rows. Now also we have the number of unknowns as 3. The number of unknown variables 3. Now when you look at both of these two numbers, the rank and the number of unknowns, we see that the rank, the value of the rank, is less than the value of the number of unknowns, right? So we have 2 which is less than 3. So when you have such an instance where the rank of a matrix is less than the number of unknowns, it implies that the equations, the system of equations, has infinitely many solutions. So let me just write that down on the top corner here. When the rank is less than the number of unknowns, this implies that the system of equations has infinitely many solutions. So if we go back to the options given to us, this matches option B. The system will have infinitely many solutions for any given values of B1 and B2. So that's the final answer, and I hope this has made sense.